So let's tie this all together here. So we have some properties that we see here, okay? So the key is this. Remember that sigma notation, it's just a shortcut for writing out long strings of terms, okay? So it just kind of writes it in a simpler way. And we can do lots of algebra with sigma notation because it just represents a bunch of things added together, okay? So some properties that are important to know is this. If we have a summation and there's a number, a constant, then we can just pull that out and it's the same. In other words, if we have the sum of I equals 1 to n of, let's say, 5 times I. Well, that 5 can just get pulled out. That's the same as 5 times the sum of I equals 1 to n of I. Okay? Which, by the way, we could go ahead and figure this out. This is, well, we have a way to write this, don't we? Wasn't that n times n plus 1 over 2? That's what we did on the previous page. So this is just 5 times n plus 1 all over 2. Okay? So, but the key is that 5 gets pulled out. Okay? And if we're adding two things, we can split them up. Okay? If we have the sum of two things being added, we can split those up. So let's see an example of that. So if we have the sum as I equals 1 to n of, let's say, I plus 2i. Actually, let's try this. Let's just make that 2. Okay? This can be written as the sum as I equals 1 to n of I plus the sum of I equals 1 to n of 2. Okay? And if we want to write this out, then this first part just becomes this guy right here. Well, that's the sum when summation of I, so it's going to be 1 plus 2 plus 3 plus 4 plus 5. Okay, and that's just n times n plus 1 over 2. Okay, this guy right here means this. When I is 1 for the first term, we write down 2. For the second term, when I is 2, notice there's no I here. We write down 2 again. For the third term, notice there's no I. So when I is 3, the term is still 2. Okay? So if I keep this going, and we go dot, 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 and we add up n of these guys, what is it going to add up to? Well, it's going to add up to 2 times n. So when we're adding a constant in the summation there, okay? Well, that's just 2 times however many 2's there are. In this case, n. Okay? That's how we would write that as a formula. Okay? All right. So our formulas that we saw on the previous page there, okay, actually we just saw this one here. If we're adding a constant, it's just going to be the constant times n. Okay. If we have the summation of I, that's going to be n times n plus 1 over 2. That's one to memorize. Okay. And this guy we got to memorize. And we probably should memorize this one. This one is useful. Okay. Even though it's a little more complicated, if you're adding squares, you got n times n plus 1 times 2n plus 1 over 6. Okay. We'll work with that one. This one, we're not going to use a lot, so don't worry about memorizing it. But we can look it up, and formulas exist. So if you have I cubed, you can write like that. Okay? Okay. So one quick example, and we'll wrap this up. Here we have a formula, and we want to evaluate this for n equals 10 or 100 or 1,000 or 10,000. Okay? Well, what's going on here? So we have, if n is a number, okay, maybe n is 10, okay, then this is just the sum as I goes from 1 to 10 of I plus 1 over n squared. Well, what is n? N is 10 squared, which is obviously 100. Okay? So if it helps, you know, we can write this out a little bit. The first term, when I is 1, first term is going to give us 1 plus 1 over 10 squared. Then, when I is 2, we're going to put 2 in place of I. We get 2 plus 1 over 10 squared. And then we get, when I is 3, that's the next one. We're counting our way up to 10. 3 plus 1 over 10 squared, so on and so forth, dot, dot, dot. And then this whole thing's going to end when I is 10 plus 1 over 10 squared. Okay? Now we can figure out what all those are there, okay? But notice they've got a 10 squared on the bottom, or 100, okay? So this is, let's do a little bit of algebra, okay? So this is going to be the same as I equals 1 to 10. Let's rewrite this. Isn't this the same as 1 over 10 squared? And here we have a constant times this parentheses, so we can pull this constant out, right? We had a little formula, a little rule that told us that, okay? So we can pull that out, and so we have 1 over 10 squared, or I'll go ahead and put that as 100 now, times the sum of I equals 1 to 10 of I plus 1. Okay? Well, we can break that up there, okay? And we can say this is 1 over 100 times the sum as I goes from 0 to 10 of I plus the sum as I goes to, whoops, what's that 0 all about? 1 to 10. So I goes from 1 to 10 of 1. We're going to put this little 1 there. Okay? So this is 1/100th. This guy right here, it's just going to be 1 plus 2 plus 3 plus 4 plus 5. Well, that's going to be n times n plus 1. In this case, we have n is 10. Okay, so it's going to be 10 times 10 plus 1 all over 2. We're just adding up 1 plus 2 plus 3 plus 4 plus 5 all the way up to 10. Okay? Plus, well, here we're going to add up 1 and a 1 and a 1 and a 1 and a 1. We're going to do that 10 times. So it's just going to be 1 times 10. And we've got to remember that this is in parentheses there. Let's get some blue parentheses. Okay. So let's clean that up, and we'll be done with this part. Okay, so we got 1 over 100, and this is on top 10, let's see, that's actually 111 divided by 2 plus 10, so that's just 55. This is 55 plus 10 is 65, right? And we got a fraction, 65 hundredths. Okay, divide by 5, I think that's 13 twentieths, something like that. Okay, there it is. Okay. So if we add up those terms, we're going to get some interesting fraction there. Well, we don't want to do this every time for all of these guys, 100, 1,000. It'd be easier to do this as with variables first, okay? So let's simplify this with variables, okay? So, going to do the same kind of steps here. I equals 1 to n of, let's rewrite this as 1 over n squared times I plus 1. Now, n is actually not changing. N could be this number, or this number, or any number. But n is constant. So this is a tricky one, but n is constant. Since it's constant, it's not changing. It doesn't have to live inside this summation. So we're going to pull that out. That was one of our properties up above that we saw. Okay? And so pulling that out, we get this 1 over n squared times the sum, as I goes from 1 to n, of the I plus 1. Now we can break this up into two summations. This guy's just going to hang out outside. Okay? So we've got the 1 over n squared times the two summations. 1 to n plus the summation of 1. Okay? Keep on rolling. 1 over n squared. Now remember from the previous section there, from the patterns we saw, this is equal to n times n plus 1 over 2. And this guy, we're adding up a bunch of 1s. In fact, we're adding up n 1s. 1 plus 1 plus 1 plus 1, so on and so forth, n times. And when we do that, we're just going to get n times 1, or n. Okay? And there it is. We could clean this up a little bit maybe, but I don't think it's going to get too far. We got 1 over n squared. This is n squared plus n if you distribute this guy out. And maybe let's write this as 2n over 2 to get a common denominator. And we could write this as 1 over n squared. Combine that here. We get a 2 on the bottom. We have n squared plus 3n. Okay. And this is n squared plus 3n all over. Multiply the bottom. N squared times 2. That's 2n squared. Okay. So there's the general formula. And how that helps us is now, if we wanted to figure this out for 100, we just plug 100 into here, and you get your answer. Do 1,000, plug in 1,000. Do 10,000, plug in 10,000. Okay? And if we plug in 10, we should get this. That might be a good check. Let's finish off with that check. We're not actually going to plug in all those ones. We've got everything we need, but let's not waste time doing that, right? So, but let's just check it out. Let's see if we actually got 13 twentieths. If we plug 10 into here, we have 10 squared plus 3 times 10 all over 2 times 10 squared. Okay, this is 100 plus 30. That's 130 all over 200, which is 13 over 20. And what do you know? That's what we got over here. Okay? So here we solved it algebraically. And this way we did it just for 10 by plugging in and using our rules to simplify. Okay? All right, well, we'll leave it at that. That's how we simplify a summation. It just takes practice. So keep at it, and it'll come. key is these formulas up here that we figured out, okay, and applying those. So get used to those. You'll get it down. Keep it up.